Hi guys, today I learn about what is spectrometers and its detail. A spectrometer is a scientific instrument used to measure and analyze the spectrum of light or electromagnetic radiations. It allows scientists to study the properties of light such as intensity, wavelength, and frequency and provides valuable information about the composition, structure, and behavior of matter. Here are some key details about spectrometer. Number one, types of spectrometer. There are different types of spectrometer designed to measure various regions of the electromagnetic spectrum. Optical spectrometer, also known as visible spectrometers, it measures the visible light spectrum from about 400 to 700 nanometers. Infrared spectrometer, it measures the infrared regions of the spectrum that lies beyond the red end of the visible spectrum, typically from 700 nanometer to 1 million millimeter. Ultraviolet spectrometer. Ultraviolet spectrometers measures the ultraviolet regions of the spectrum that lies beyond the violet end of visible spectrum, typically from 10 to 400 nanometer. X-ray spectrometer. It measures X-rays which have wavelength ranging from about 0.01 to 10 nanometers. Mass spectrometers, it measures the masses and relative abundances of ions to determine the molecular structure and compositions of substance. Components of a spectrometer. While the specific components can vary depending on the type and design of the spectrometer, the basic components include light source. It produces the electromagnetic radiation to be analyzed. In light, it controls the width and angle of incoming lights, improving resolutions. Monochromator. It disappears the light into its different wavelength or frequencies. Detectors, it captures and measures the intensity of the light at different wavelengths. Data display analysis system, it processes the detected signals and provides visual or numerical output. Working principles. The working principle of spectrometer involves the following steps. Light from the source is focused on the entrance slit to ensure only a narrow beam of light enters the instrument. The monochromator disappears the light, separating it into its constituent wavelength or frequencies. This disappeared light is then directed onto a detector which measures the intensity of light at each wavelength. The detector generates a signal proportional to the intensity of the light, which is processed and displayed as a spectrum. Application of spectrometers. Spectrometers have a wide range of application in various scientific fields. Chemistry. Spectroscopy is used to identify chemical compounds, determine their structure, and analyze their concentration in samples. Physics. Spectrometers are used to study the behavior of light, investigate atomic and molecular interaction, and analyze materials. Astronomy. Spectrometer is vital in studying the composition, temperature, and movement of crystal objects in space. Environmental monitoring. Spectrometers are used to measure Pollutants analyze water quality and monitors atmosphere conditions. Medical diagnostic spectroscopic techniques are used in medical imaging such as magnetic resonance imaging and near-infrared spectrometers. For diagnostic purposes, spectro played a crucial role in scientific research, analysis, and industrial application, enabling scientists to understand the fundamental properties of lights and the world around us.